So, Brad, this morning as I was making coffee before we recorded, I was pouring the coffee and updating all of my iOS devices simultaneously.
Yes, as one does in the year 2023.
Just a perfectly normal thing to do. And I was thinking, what would be nice if this update had happened last night automatically without me having to think about it. And also if I had a coffee refractometer so I could see how well I was extracting my coffee.
Again, normal morning thoughts for 7:30 in the morning.
This is just the way my brain works. I can't, I feel like I want to dig into both of these, but I don't know where to start. So I'm going to leave it up to you. It's a choose your own adventure,
Dude,
Brad.
That exploit was a rude awakening at 6:30 this morning when I first read about it. Holy.
You mean, hey, let me send you an image and it will totally pwn your phone.
It's 12 o'clock. Do you know where your iPhone is?
Did you know? I didn't know about lockdown mode on iPhones until then.
No, I didn't either. We should step back and just talk about there's a very bad iOS exploit in the wild now.
It's I think it affects everything. iOS, Mac OS,
yes,
the whole thing, all Apple stuff. So update your Apple devices today.
The distinction is, and it's right here in italics. I've not heard of the Citizen Lab. Are you familiar with them?
Yeah, they do. Like they're a public service. This is how they bill themselves.
I gather they're one of these kind of watchdog groups that identifies CVEs.
Well, there's money in bug bounties, right?
Yes.
Like big companies pay a lot of money for people who find new exploits and stuff like that.
Yes.
And you can fund a business that way.
Yes. So even they, in their disclosure, have this in italics. The exploit is capable of compromising iPhones running the latest version of iOS, italics, without any interaction from the victim.
Yeah.
Like that's the part. That's the part. That's the part that makes it so crazy. I don't think I've ever seen an exploit where you didn't have to click on or activate or run something malicious actively before you were exploited. But
Brad, let me tell you about the great worm situation of the early 2000s, pre-Windows XP SP2.
Look,
you could just plug a computer on the open network and it would be infected in like 8 minutes.
We've talked about this before. If you're going to run on the internet without a firewall, there's no helping you.
It was a gentler time, okay?
Yes. But yeah, this is literally, if you get an infected iMessage, your phone is compromised. That's it. Yeah. All they have to do is send you the right payload through an iMessage and you're fucked.
Yeah. So if you're listening to this on Monday, it's probably already too late.
You should probably just light your phone on fire at this point.
Hack the planet.
No, it's whatever. I mean, you'd have to be actively targeted. This is probably something that only public figures need to worry about. But really, it's probably something mostly that only people who run afoul of nation states have to worry about. But still, it's bad.
Well, I mean, you say that, but unlike most other exploits of this variety, this one they did find in the wild. So it's bad. Like it's out there.
They discovered this one because of someone's phone that they analyzed that had already been infected by it.
On the other side of this, the coffee refractor is a thing that you put a little drop of coffee in. It tells you how many, what the percentage of solids is it's in the device.
Dude, that's some Star Trek shit. I've just been thinking about that as I continue to dabble with cold brew coffee. And I have cut caffeine mostly entirely out of my life.
Oh, God, I'm sorry.
It's for the best. It's for the best. Well, let's say we have so much caffeinated coffee left that I'm still... I flouted your advice and bought a 5-pound bag of decaf.
Yeah. How's that going for you?
That's fine so far.
Okay.
Anyway, I'm cutting decaf and caffeinated. So it's just another variable in the chain of what am I getting out of this cold brew? It's like.
So it's funny because the last time I looked at this, getting a refractometer was like a better part of $1,000. And now there's some that are like $80 on Amazon from China.
Okay.
And I'm like, maybe I'm going to get one of these. Seems like what is there a bad idea? Well, this one's like a visual one that you look through.
What are we getting out of this? Like caffeine content, like oil composition?
Solids dissolved in the water. Like how much stuff is in the water.
It's just kind of how saturated is this liquid?
It lets you know how much you've extracted out of the beans and into the coffee.
But you don't know what compounds or anything like that?
I mean, if you ground up coffee and put it in the water, you know that it's coffee compounds.
Okay, fine.
It's not like a spectrometer that'll tell you this is this much carbon and this much phosphate and this much. Look, I can't tell you that it's some sort of magically corrosive argon gas, Brad. I don't understand that.
I'm mainly just curious how much caffeine is ending up in there. But
I'm sure that there's some sort of calculation you can do based on but that I think you have to know how much caffeine's in the beans, and that varies from varietal to varietal, I believe. So anyway, there you go. Refractometers, update your iOS devices.
Sounds like it's time for a podcast.
welcome to Brad and Will Made a Tech Pod. I'm Will.
I'm Brad. I'm Brad.
I'm Will.
Okay, just in case it didn't take the first time.
Sorry. Look, school has started now, okay. And as a result, during the summer months when we podcast, we often podcast early in the morning, and I get up and I have the house all to myself. I have an hour and a half usually before we go where I can finalize show notes and I can get my stuff together and have a little bit of quiet Will time to prepare for a pod.
Sorry, I started to say, wait, are they leaving for summer camp at 6 a.m.? But then it occurred to me, they're probably still asleep.
Everybody else is still asleep.
The idea of sleeping past 6 o'clock is hard for me to fathom at this point.
All the decent people in my house are asleep until 9 during the summer.
Oh, that sounds good.
Yeah, it's nice for them. So now during the winter months when school's on, everything starts at 6:30 and it's full chaos for an hour and a half.
Sure.
And they leave at about 7:50. So that means that I have 10 minutes instead of the traditional 90 minutes to do my podperation, right?
Look, you've done some pretty good podperation here in 10 to 15 minutes.
Yeah. So anyway, there we go. This week, we're going to talk about the kind of stuff that people don't talk about making video games often. Working in a small studio, I've gotten to engage with some of this, not all of this for sure.
You make it sound so salacious.
What do you mean?
It's the stuff nobody talks about.
It's the filthy underpinnings of the game industry.
Talk about
dirty secrets we don't want to hear about, like Perforce servers, and talk
about such scandalous subjects as your build server.
Yeah, you want to come down to TeamCity with me, Brad? TeamCity makes the build server software that we use.
I'm sorry. What is it
called? TeamCity.
Oh, I thought that was a Microsoft Teams joke.
No, we use Teams too. We love Teams. It's a fine Seattle studio. Nothing better than a good Microsoft product.
Oh, TeamCity is a JetBrains thing.
TeamCity is a JetBrains thing. They make that is literally okay. So anyway, we're going to talk about the things that are the back end stuff that makes game studios work and that make it easy to publish games.
Or as I like to think of it, we're going to talk about how you build a video game, not how you develop and make a video game, but how you turn all that work into a functional running program.
Yeah. So for example, when I make a change to the sound stuff in the game, I submit it to our source control software. Which we use Perforce. It's popular in the games industry. We'll talk about that in a minute. Then that goes up onto the source control server, and at some point in the future, somebody will say, "Okay, hey, or realistically, every night at 3 a.m." Our build servers look at the source control stuff, and they're like, "Hey, did anybody submit anything today?" If they did, then we'll make a new build. And if not, then we'll just use yesterday's build stays. And then those get built, they get uploaded to Steam, and the next morning our internal branches are updated with the latest daily playtest build, which is our the current. It's equivalent of a nightly in open source context.
I started to say, I'm sure every studio is different. I'm shocked to hear it's that automated, not the build process, because of course why not automate nightly builds?
Yeah,
the part where you deploy it to Steam, even though I'm sure that's filtered to a few testers, that's certainly not for public consumption. But the idea that a build is going out the door even to testers without anybody touching it is kind of crazy to me.
Well, so that internal build is just internal.
That's not even for external testers.
We don't generally. Okay, we have in the past made those builds available to external testers, but so there's okay. Let's take a step back.
Okay,
most studios probably have at least 2 and probably 3 to 5 private builds, or plus the release build that everybody that's bought the game has access to. So there's going to be a debug / development build that has all the hooks that people can hook their engine tools into to see what's going on inside the game, right? And that you don't want to put out. There's usually if it's a multiplayer game, there's a staging environment or a development environment one where you can hook into the server and see the same stuff. Sometimes those are the same build. In our game, they are. There's a private testing pre-release, a release candidate build that's essentially a ready to ship to machines build. So there's development builds, there's testing builds, and then there's builds that you give to customers, to players. And there are different divisions inside use. Usually the testing one has some debug hooks and will dump extra debug stuff. It may have cheats enabled so that the QA folks can bypass can spawn specific weapons. Like if there's a change to a weapon, you want to spawn like 50 of those and try in a bunch of different circumstances, stuff like that.
Yeah.
In multiplayer game, you obviously don't want to leave that stuff in for the shipping build. And then there's the shipping builds and the shipping candidate builds and all that stuff.
Yeah. This is just kind of tangential, like having covered console games for a long time. I've always assumed that's why, or that's a big part of the debug stuff is a big part of the reason that console dev kits are so much beefier than the actual console hardware, because you need a ton of extra memory and maybe extra compute to handle all the crazy extra debug stuff you have to run on top of the actual game.
That's my understanding of that. That's a double-edged sword because you can use debug kits to test, but we had a bug with one of the Xboxes, I think, that it didn't happen on the debug kits because they had that extra memory.
That's I was going to say, it seems like you'd have to do some very meticulous like resource and performance profiling to make sure you're not exceeding your eventual hardware target budget.
We did not realize that was a problem. Well, so we didn't realize it was a problem when we were testing because we assumed that when you flip those to retail mode, then they work like retail kits, but they don't.
Anyway. That sounds like in an Xbox context because that's the only one that's got modes of that nature.
I believe so. Yeah.
Okay.
But we only ship on Xbox. So,
yeah.
So you have all these different things. Each of those is a pipeline in your build server, right? And the build server has basically all of the stuff on it that you need to make the game, either the debug versions, the testing versions, the shipping versions, whatever, and on all the platforms that you release. So like it'll have all of the libraries and all of the compiler stuff. And what it has on it varies widely based on your game, the platforms you ship on, whether it's a console game or a PC game, whatever. But the build server knows like, hey, grab these commits, hook into the different API versions, and then you need to make a version for Steam, you need to make a version for Epic, you need to make a version for the Xbox One, for Xbox Series, for Windows Store, all the places you might ship the game. It'll build those, and each of those takes time. Like it's a fairly involved process.
God, I could probably spend the rest of this podcast talking to you about your build server and the concept in general, from everything from like the general specs and how they're built at a low level to like how you manage different build environments based on compile targets and platforms and stuff like that. Like I'm sure it varies. Like, I'm trying to think like what's the biggest Ubisoft team out there? I mean, your studio is quite small. A lot of the indie developers are just a single digit number of people, but then there are like hundreds strong studios out there, like 500 people or something these days, or Bungie is like gigantic, right? So like, I'm sure what constitutes like a build server or build farm is very different as size scales. Yeah,
we have a baby build farm. It's only like 3 machines.
Even though I'm actually surprised even at your size that it's multiple machines. I was going to ask, like, is it all just kind of, I assume, off the shelf commodity hardware these days? I mean, CPUs are very fast in general, right?
Yeah, I think I feel like more cores and more memory. It's a real write churn intensive thing. My guess is like we've been looking at upgrading our build servers at some point in the future, just because at the time we built these machines or bought these machines, I don't think that there were a lot of really large NVMe SSDs available at a scale that we could. So you have to have a lot, like there's a lot of space. It requires a lot of space. So if you like, our game is like 16 gigs on Steam, which decompresses down to like 30 gigs when you unpack it. And to do the builds and you have to have all the source code files. You have to have the compiled binary assets that make up the game in the Unreal project, all that stuff. It's big. It's like 500 gigs of space for the project, for the current version of the project.
That's pretty big.
Yeah.
I mean, like a relatively small scale game. I'm not saying like your game is small or whatever, but like
our budget was like $8 million.
Right,
it's not a big game,
right? Yeah. Like it's a focused game. It's a multiplayer only game, more or less. And that's like you said, that's half a terabyte for an indie multiplayer game. Like imagine what the total kind of asset or package size is for like your average sprawling console RPG.
Yeah, to give you some context, I think Chet likes to say that Far Cry 6 had more studios that worked on it than we had people that worked on the Anacrusis.
Sure.
And some of those studios, like the Ubisoft Shanghai, is like 1,000 people. They're enormous, right?
Yeah.
So they have a whole, like, where we had a person who did this for a while and then it shifted out to be part of somebody else's job or a couple other people's jobs. This at some place like Ubisoft, I assume that there's entire teams that do nothing but this kind of DevOps work, right? Where they're, everybody has their own perforce and then stuff filters up and their nightlies are real weird. I'm sure. I don't even I can't even, the amount of art that goes into something like an Assassin's Creed. I can't imagine that you have a daily build cycle. And then you hear about things like Destiny 1 where Bungie had problems with their back end, and like they had just to be clear, the build server doesn't do the computationally expensive stuff like build light maps and stuff like that. That happens, either an artist does that or we have a light map machine that does that.
Interesting. So when you say an artist does that, would they have that surely they wouldn't have that hardware at their desk, right? I assume that's like heavier iron than like would be in an end user context.
No, okay. So for our game, again, this is a place where things differ based on the scale of your game, right? Yeah. On our game, I can run the light maps in like 40 minutes on my 4090. Oh, okay. Because there's a GPU accelerated light map maker now. Of course.
See, my brain is very stuck in the 90s, back when like every like Quake licensee had a light map.
Have an SGI machine in any place running this stuff,
like running radiosity calculations.
Yeah, no, I mean the ray tracing stuff has accelerated that pretty dramatically. Sure. It's not real time, but it's like it's gone from hey, you start this before you leave work at the end of the day, and then you come back in the morning and it's maybe done. To hey, you can hit the button and like on a 3070, it'll be done in like an hour.
Okay, you can go eat lunch and come back and
go eat lunch, maybe take a nap.
Yeah, I guess this is a good time to point out like the stuff we're talking about in terms of how fast you can crunch calculations and produce a build. Like that has very real implications for workflow, right? Like how fast you can check changes in and get a build out and test them, like just dictates how fast you can move on to the next thing, right?
Yeah, and so we have So the two things to take away from this are even a simple game that's only shipping on 2 platforms. We ship on Steam and Xbox right now. When we release something, it makes 5 builds, right?
Okay.
So each of those builds takes an hour to 2 hours. A lot of that is just disk churn. There's not a lot of complicated stuff. It's not like we're making light maps or something on all of those builds. And like that takes a long time. We also have we want to do something quick for testing that just jams it up on a special Steam branch, and that's like an hour and a half. But it still takes time. It's upload bandwidth and it's the compiling time and all that kind of stuff.
Yeah, I assume it's probably safe to say that the common commercial engines like Unreal and Unity have focused on iteration time as a
I don't think they give a flying fuck about iteration time.
Okay, never mind then. Well, you mentioned the Bungie example, which, like, from my understanding, that was just like a legacy tech issue. They had just been working on the same core architecture in their engine for so long that there were just legacy things that made it, because that was very widely reported about the first game, that kind of like you said.
Yeah, it took 12 hours to see a map change or something nuts, right?
Right, like replace one pickup in the map. This may not be 100% accurate, but it will make a very minor change to the map, and then you'd have to wait like all night and come back the next morning before you could test the map again.
Yeah, I think so. I don't know about Bungie's example in particular, but the other thing is, so I say that I don't think the engine makers give a fuck about that, but like Unreal has play and editor, right? So you can hit a button in the game and it'll load up the game with whatever kind of starting state you say. So you can say, okay, I want to play in versus mode. I want to play in survival mode. I want to do this. And then you can play through the game in the editor. It's not exactly 1-to-1. Like there's some places where it's a little bit weird. And you can put yourself in trouble there. But if you're making like, for example, when I'm making audio changes, I can make my change, hit the play and editor button, and get a pretty good idea of what the end result is going to be.
You mean when you're getting your WAYs on?
When I'm getting my WAYs on. If other stuff is less, like light map changes, you still have to make the light maps if you want to see what happens. And there's always did this run right, or was there some weird math glitch? Did a cosmic ray hit the GPU at the wrong moment and jack up the whole thing?
Whoa.
But that usually results in like weird artifacting, not
a broken build.
Not a broken build. The thing about Like light maps are a weird one because it's always a balance between, hey, how long do I want to bake the light map? And hey, what level of janky artifacting am I okay with? And a shadow in a corner of the map that nobody ever sees. And it turns out the answer is you're probably okay with a little bit of artifacting in a weird corner that nobody ever sees.
Sure.
And if that's a continual problem, then you can put something in that corner that will kind of fix that problem and tell it to spend a little more time there.
I don't know if this is getting too like 3D graphics engineering for you, or if you can speak to this, but like, can you elaborate on like what constitutes a light map in 2023? Like I hear a lot about light probes. Like, are those synonymous at this point? Like, I don't know what and also, are we talking about fully static lighting at this point? Like, are those types of quote unquote light maps like things that you place and then don't move? Like, is that still, how does that work these days?
Yeah. So depending on the platforms you're shipping on, for example, like if you're making an Oculus Quest game, you can have a relatively meager number of dynamic lights. Dynamic lights are lights that can move, that can be on or well, I mean, light map lights can be on or off too, but the upshot is
vary in intensity, move around, stuff like that.
Yeah. You can affect color. Them programmatically during the gameplay, and they are on traditional hardware very expensive. Like they call it, especially on mobile stuff, they're really expensive to run.
Which is why like lighting has been like the it's hard to say the holy grail, but that's more like the white whale. I feel like of 3D graphics since the beginning of time, right? Like that's always the thing that takes the most work and that people throw the most different like techniques at the wall to try to solve.
Well, and it's a thing that our brains know what light does in the real world. Just instinctively, we understand it. So it's a place where when the light doesn't look right, you know it, and you're like, this doesn't look good, or it's alternately you can go with a really stylized approach, and then it doesn't matter if it looks good. You just have to be internally consistent. There's a bunch of different ways to cheat having a bunch of dynamic lights in the game. That's the kind of TLDR, and the different engines use a bunch of different ways. Inside an engine, you can choose to use a bazillion different ways. This is one of the reasons people are excited about UE5 is that because of the things that they're doing, you can have dynamic lights because of the way they're using the ray tracing hardware and some stuff that they've done on the back end of the engine. Dynamic lights as a solution for your game are much more viable than they have been in the past. So you can have a game that is entirely dynamic lights, like the sun is a dynamic light. And like, so for example, in PUBG, the sun moves across the sky, right? But they move the sun across the sky by generating light maps at all the different positions that the sun can be, and then blending between them as the time changes in the game.
Yeah. Is that why in some games, if you look at kind of the shadows on the ground, you'll see them moving in very rigid increments?
Yeah. Yeah. And so they don't blend between them when they're moving in rigid increments. Right. But at the end of the day, all a light map is a texture that says how bright a part of the map is. Right. And then the light probes and stuff like that are just further refined, give you more control over specific subsets of the game and stuff like that, or dynamic control over different areas, stuff like that.
Right. So like fully, not to turn this into lighting chat, but like fully generalized dynamic lighting has that's the holy grail that I was talking about. Like ever since like Doom 3, it's always been like different techniques of chasing. Like we don't want to have to bake any rigid unchangeable lights into this game. If we can make everything work in the same way dynamically, then or even in different ways dynamically.
And typically game lighting doesn't work the same way that light works in the real life. Yeah. In real life, a light source exudes photons. The photons bounce off of things, and then the photons that smash into your eyeballs represent colors and information.
Right. And like their wavelength has changed based on what they've been absorbed and re-emitted into.
In a video game, typically you blast rays out from the eyeballs and you see what you can see, and then you kind of you reverse engineer into what color those should be.
Yes, I was going to bring that up. As I've read a little bit about the current ray tracing techniques, I was surprised to find out that they do it in reverse of the way that it works in the real world. It turns
out it's a lot cheaper because you don't have to do a bunch of pixels, a bunch of rays that nobody ever sees.
Yes, so like that stuff is super fascinating, and I can barely speak to it, although I was actually just looking at the Reester white paper yesterday. Are you familiar with that?
I haven't read it yet.
It's what Cyberpunk uses for their path tracing mode. It's a relative. I think this white paper was published in like 2019, 2020. It's just a new algorithm for ray casting that is like wildly more efficient. It's probably like less accurate if you're running an offline render farm and you want pure image quality.
Yeah, but Pixar's not going to use that, but it's great for video games. It sounds like
RESTIR. Like the math is super over my head. I didn't even bother trying to understand it. But if you Google that, you'll get straight to the NVIDIA like research page for it, and you can see a picture of like here's the kind of like, it's not a point cloud, but what is the, the undenoised, like just the speckled image that you see of like, here's where every ray hit a surface with the traditional algorithm, and then right next to what Restir does, and it's like orders of magnitude more samples,
more dense. Yeah.
So it's cool. It's really cool seeing all this research stuff going on that's like massively accelerating how that stuff works. We should probably get back to building games. I'm sorry to turn this into 3D graphics time.
Well, so that's why we don't focus too much on stuff like light maps. Like we set up a big Threadripper machine in the office and let that be the light map server. And then the artist can say, okay, I need to bake level, episode 3, level 2. And that sends a command to that server and it runs the light maps. And like an hour later, it uploads, it makes a commit to the source control. That's like, hey, new light maps for episode 3, level 2.
That's okay. That's interesting. So that's what I was wondering about when I said like, are these types of servers just commodity hardware these days? Like Threadripper is not exactly end user hardware, but it's also not $100,000 supercomputer type stuff. Like you said, that's like, what is like a decent Threadripper build is like $5,000 or something.
Yeah. I don't think we even spent that much.
Okay.
But yeah, basically the build servers will benefit from more cores, but you don't need like a workstation, like a multi-core workstation machine. You just need something with a shitload of core. You just like a Threadripper or a big Intel machine will totally do it. And you're probably better off, given that while one build is building, like we would be better off having 4 small machines than 2 big machines. I think we have 2 big machines now. And because we have 5 builds to make when we hit the button, and they can't run in parallel on the same machine, we would be better off having 5 NUCs with a lot of storage attached to them than 2 big 64 core machines, which is what we have now.
So are those 2 machines not in some kind of cluster situation where they're both working on the same? Is each one doing a discrete build?
Each one is doing its own build because of the way the build process. You can't come. Yeah, I guess theoretically we could put VMs on them, but also you pay for TeamCity based on the number of machines that you have. So like as with everything, you can put a bunch of numbers in a spreadsheet and then you get a curve where you're like, okay, here's the sweet spot. We're willing to pay this much money a year to get a build in an hour versus a third of that to get a build in 2 hours. Right. Sure. And it turns out the 2 hour number is usually the right number.
Yes.
Okay. So then once the builds are made on the build server, theoretically, if you set yourself up right, it should just go to the platforms. Like it should just be uploaded into the back ends of the platforms.
Disclaimer.
So some are more reliable than others.
Okay.
There's a button in TeamCity that you can press that's like, hey man, rerun the upload process. So TeamCity sets this up as like, I've used Jenkins before in the past, which is a similar piece of software that's open source, but TeamCity sets this up as a series of tasks. So it's like build for Steam, build for Xbox, build for Xbox One, build for Windows. And then the next step in that chain is deploy to Microsoft, deploy to Steam. So like if the build completes correctly and it doesn't deploy, you just hit the deploy button and it uploads it again and it's fine.
Okay. I didn't realize TeamCity also handled the uploads and like hooked into those backends directly. Is that built in or is that something that you have to like script? Like here's the upload target for Steam. Here's like the API keys. Like, do you have to kind of like build that part yourself sort of?
So yeah, I didn't set this up on our end. I did it for our Jenkins server when I was at Foo, but basically like Steam stuff is probably, Steam just has a bunch of command line utilities that you can script into. So it's a lot of PowerShell scripting, right? And from TeamCity's perspective, this is all just PowerShell scripting, and it has hooks into some of the compilers and stuff like that, so you can see how it's going. But mostly it's just like, hey, I'm going to run some scripts in a sequence of orders, and then I'm also going to archive a bunch of files for you. I know how to handle the file archiving bits, but also that's probably PowerShell scripting too. I haven't actually looked at those to see how they work, but it's basically when you're setting up a small game studio, it's good to have one person who's really excited about doing PowerShell scripting.
Oh, yeah. You don't say.
Well, because all this stuff has to run on Windows, right? You run this on Windows because that's where your environment is, and if you're shipping to Xbox, I guess you have to. They probably let you build on Linux now, but realistically, you're going to run on Windows for most of this if you're a small studio.
That makes sense. I wonder. I mean, if anybody, any game devs listening to this, I want to write in. I wonder if the WSL2 changes that at all. Like if Linux build environment on Windows is more viable now that that's a factor?
So we set that stuff up. Well, you could definitely build a Linux build on Windows.
Oh, a Linux build, yes.
We could build a Linux build, no problem if we wanted. Supporting a Linux build is a whole other issue.
No, I meant like managing your whole build environment. That probably doesn't make sense. Like you want to build you want to build for the OS on the OS, right?
Yeah, I don't know what the Unreal Linux situation is. I know that they have a Linux pipeline, but I bet it's from Windows. I don't know. I haven't looked at that. But supporting Linux is fraught with peril.
Yeah.
I love Linux as much as the next person. I think everybody knows that. But the beautiful thing this team has done is let us support Linux without having to actually test more stuff.
Yeah.
Because the other thing is each of these builds adds testing overhead, right? Like every time you make a new version of the game that you have to release to people, you have to test stuff. And with a small team testing 5 versions of the game, even just to test the stuff that we change from build to build. So that's we've kind of gone a little bit out of order here, but you just testing the stuff you change is a huge task, right? If you have a patch that has 20 changes and you have 5 versions, that means you have to test those 20 changes on 5 different builds of the game and see what works and what doesn't, and if there's any weird regressions, and like it's complicated.
Do you as a studio have like a standard suite of tests outside of, like you said, like if you change 5 things, of course you have to test those 5 things, but like is there also like just a short checklist of like these are the basics we have to reconfirm every single time there's a new build that these work? Or
well, that would be a good idea.
Okay, I mean obviously that's constrained by resources and human power.
Yeah, I mean, we do have a list of things that we test, but I mean, also the game's early access. So, like, if we were releasing, we're a relatively small game. We're in early access, and also we can move quickly, so we can release a follow-up patch within a day, basically. Yeah. So we typically ask our wonderful community of players to help with that kind of stuff and let us know if we've done something really bad, because the challenge of, hey, if we change something about the way matchmaking works, we can test matchmaking a little bit internally, but not really. We can't test across regions and stuff like that because we only have people in the United States. So it's difficult for us to find out if we've actually messed something up with matchmaking until it's actually on the live game is the unfortunate thing.
Right. And my assumption is, like people might be listening and thinking like, well, if you only change 5 things, why do you have to test anything other than 5 things? But my assumption is that it's very hard to predict second and third order consequences of seemingly, I mean, it's straight up a butterfly flaps its wings on map 2 and type stuff. I don't know.
So yeah, a lot of stuff's interconnected. A lot of stuff, like for example, the attenuation profiles for environment sounds in the game are often shared across levels, which is a choice somebody made a long time ago that seems crazy now, because it means that I can
you to this day.
Yeah, it means that if I change how far away you can hear a fan on level 1 of episode 1, then all of a sudden a big huge blower on episode 5 or 4 is going to sound like a jet engine, and I won't know it until I play episode 4 3 days later. The better example of that probably is something like the player's collision capsule had to change a few months ago, and that, given whoever wrote the AI code for the bots, when a player gets gooed in our game, gets incapacitated, you shoot them to knock the goo off of them and free them. And the person who wrote the bots was like, oh, the player collision capsule is a little bit off, so I'll just aim at the 20 pixels right, 20 units right of the collision capsule in Cartesian space to free them when they get gooed, and it'll just work itself out. And that was great until we fixed the collision capsule, and now all the bots are shooting 20 units to the right of where the player actually is. So the bots just don't ever free players anymore. Right. And like, how do you? I mean, we find that out because we play every day. Yeah, that's a bad example of that. But like, if that was a and if we change something about the way you invite friends to the game on Steam and that had knock-on effects on Xbox, we might not think to check that because who knows? Anyway. So that's what build servers do. Like they make the game, they turn the code into game, and then they push the game to the server if you've set everything to the platforms. And then from there you can go to a UI thing and push the build live, where you open up a web interface someplace and you're like, okay, I want this upload to be the live game on servers right now.
I want to ask more about the build process. I don't want to get too much into the weeds, and I also don't know how much of it you set up yourself.
But I didn't set up any of the build process. I didn't know how to go in and press the button to make a build.
Maybe that answers the question, because I was going to ask if there is just a button to press, at least with Unreal these days. Like, you're not necessarily running. Like, I'm curious about like which compiler is being used and like what's the build environment and the tool chain look like and stuff. But I'm guessing that at least with a commercial engine, that's probably all pretty much dictated and set up by the engine.
Yeah, so that's all Unreal stuff. We use some of the stuff we use, like the different APIs that we use from Microsoft for the Xbox stuff and all that have different requirements for like Visual C and XNA or X and whatever the current Xbox backend stuff is called, whatever their API package is called, that's all set up in the scripts for the compiling scripts that the building scripts that somebody set up for TeamCity 2 years ago. At this point, probably 3 years ago.
Interesting. Like there's there are starting to be some open source game engines out there now. Mm-hmm. And I'm sure those types of questions are maybe more relevant there. I mean, I'm sure they automate some of that stuff too, but like,
well, so this is, just to be clear, this isn't Unreal automation. This is stuff that we built internally. This is why having like TeamCity is a cert product we pay for that takes the stuff that I could build. Just to be clear, I could load up my computer in Unreal right now and hit a button that says, hey, make an Xbox version of this game. And I guess I don't have Visual C installed, but if I did, Visual Studio installed. If I did, then I could make a version of the game that I could upload to the Microsoft backend or to Steam, and people would be able to play.
I see. Okay.
But in order to do that, it's going to tie up my computer for an hour and a half.
Right.
And then I'm going to have to manually upload it. And actually, Steam doesn't let you upload stuff bigger than a certain size. So I'd have to get the Steam command line tool to upload it and like all the credentials and all that stuff. So this is a way to manage, like what a build server does is gives you a way to make those builds without having to give everybody in the organization the Steam keys and the Xbox keys and all the crypto stuff that you need to sign the Xbox games and all of that stuff. So it lets you keep your information secure that's important to the thing, but also more widely distribute the ability to actually make the game.
That's super interesting.
Just one person.
Yeah, that's fascinating to think about Steam as a development tool in that context and not as an end user distribution platform. Like for like you said, kind of build management and dispersal to people who don't necessarily need to worry about that sort of thing on the team.
And it's also worth mentioning that Steam is really neat because they give you the ability to put infinite. Well, they let developers hand out keys without having to pay for them or something stupid like that. B, they also let you do branches, so you can do betas and stuff like that are either public or private. People use them for all sorts of interesting stuff. Like the other day, I was poking around Dead Cells, and they have in their beta branches public versions of every past version of Dead Cells, I think, is in there.
Wow.
So if you want to go back and play launch Dead Cells, you can.
Oh, that's cool.
Yeah. Like if you have a server backend infrastructure, obviously that's not going to work. But like you can do whatever you want. When we wanted to test versus publicly, like semi-publicly, we could just generate a branch with a passcode on it and share that with the community, and then people could load it up and play the game.
Yeah. Yeah, the like all the Steam developer docs largely are public. You can go read about a lot of that stuff. Like I've looked into some of how the backend branching stuff works, and like they give you an amazing amount of granular control over like who has access to a given branch and stuff like that.
Yeah, and like it's up to us then to make sure that we don't share, for example, the branch with the developer credentials or the whatever that kind of stuff is in there.
Yeah. Real quick before we move on, just to touch on a couple of the open source game engines that I've mentioned. Godot is the big one that I hear about for the most part. GODOT.
Yeah, we're waiting for it still.
Yes, I bet they get that a lot.
Look, they named the game engine. It's their own fault.
I guess you may have a point there.
It's not like me where I was named Will Smith and then 20 years later somebody got famous. They knew what Godot was when they named it that.
Yes, I see. I mean, I don't know if this is true, or I can't say for sure this is true, but I kind of see Godot spoken about a lot in the context of like Unity. Like I see a lot of like every time Unity does something unpopular, I'll see some game developers on Twitter say like, well, maybe it's time to finally start learning Godot. So I wonder if it has similar application or similar amount of scope.
I would say disaffection with Unity seems to be pretty high in my communities right now.
Okay.
I don't know that I haven't looked at Godot yet. I don't know where Godot's at.
There's also Bevy, which
don't know about that one.
I think is pretty. I shouldn't say limited. I get the sense it's fairly early. It's written in Rust.
Okay.
And there's some people on our Discord have spoken highly of it, or at least have, I think, enjoyed tinkering with it.
It's hard to not do a commercial product if you're spending like if you think about your investment in a commercial game engine versus like the payroll of your small studio, even like with 5 or 6 people, like it's scary to not have like I don't know that Godot has a support infrastructure around it at this point that's adequate.
You absolutely want like proper support, commercial support for something like that in an actual business. I was throwing that stuff out there more as a like, hey, if you're curious about this stuff, here are a couple of free engines you can go Google and download and mess with yourself if you just want to like kind of see how some of these pieces are put together.
Well, I was gonna say also, I think both Unity and so one of the things that surprised me about all of this stuff is that at small scale, most of the software is relatively inexpensive or free. So, for example, our source control Perforce is free until you have more than 5 users.
Oh.
Yeah, I mean, you still have to pay for a server to host it and all, or you have to host it yourself.
I guess that's like been the model though, right? Did Unreal kick that off like 15-ish years, maybe 20?
I feel like the first time they did them build something Unreal thing, after that they announced that you could download it for free.
Right.
Previously it had been like you had to pay $1 million to get access to Unreal.
Right. Which was obviously smart. Like you want to put the tools in people's hands with low barrier to entry, and then once they start making money, you start taking some of that money.
I was gonna say the one thing I forgot about on the build server front is that if you have internal tooling, the build server probably also manages and updates and distributes that to people. Okay. So for example, we have a custom version of Unreal Editor because we modified our Unreal Editor to do things that were specific to the game. And when we update that, the build server does that. And then you run a batch file on your computer that downloads the latest version of it from a server someplace. Anyway, yeah, the different game engines, like everybody always wants to talk about game engines, and it's funny because as I'm further into this, like it's more and more clear that really the game engine matters way less than people think it does.
Well, like, I'm sure on the developer side, it's a means to an end, right? Like it's just a tool.
Yeah, I mean it's a toolbox, right?
Well, yes.
Because like when you buy Unreal, you're getting all of their like if you want to make a big ass open world, turns out Unreal's pretty good at that because what Epic uses Unreal to make is a big ass open world game, right? If you want to do destructible stuff, they're good at that. If you want to ship stuff on mobile, maybe Unreal is not your choice. Right? Like there are probably better choices than that. If you want to make a text adventure, Unreal, probably massive overkill, right? There's much better choices for that. But there's a lot of, there's just a lot of options out there now, which is, I think, good for everyone.
Yeah. Yeah. I mean, a lot of that seems to have come from like YouTube and I don't know how to describe like forum chatter, I guess is like kind of discussion among consumers and users about like which game looks better and runs better and what engine is it on. Oh, everybody should use that engine. Like it's just kind of a very reductive style of discourse.
Look, I'm as guilty of this as the next person. Yeah, I did a what you need to know about game engines article in like 2005 for Maximum PC. Yes. And I was like, look, Gamebryo, really, they're doing some crazy stuff up there. Look at what the people in Norway are doing at DICE. They got cool things going. And then we all know how Frostbite turned out. So my bad. But yeah, it's more like all those YouTube videos about, oh, I could tell this was a Unity game because it has the Unity look. What they're identifying is, hey, these people use Unity's default lighting model, and which is a fine choice. I don't know. It's just YouTube. I don't like YouTube discourse the older I get, Brad.
Fair.
Should we talk about source control or QA next?
I think that was source control was the first topic, but we kind of blew past it a little bit.
Yeah, it's fine.
Well, we talked about Perforce. I mean, the interesting thing here with games to me is that like when I think about source control, it's a method of versioning, right? Like just to be clear, it is a method of like keeping your code base in sync between multiple developers, managing changes and versions that you can roll back to, and et cetera, et cetera. But when I've always thought about source control, it's purely in the context of text files, which are code.
Yeah.
But then like you mentioned, you've got mass amounts of assets, sounds, textures,
sounds,
levels, like
3D models, Maya like, files,
right.
like,
and I'm sure this varies between studios, but I wonder how much. I wonder what the trend is about. Like, does a single artist generally kind of have ownership of a model, for example, like a specific character model, or are there like a bunch of different artists working on the same model at different times?
So I'm gonna say. Well, generally, only one person can check something out at a time. That's
I mean, successively, I'm sure it happens that maybe somebody else will go back and touch something up if somebody else is busy or whatever. I'm just wondering how much of those types of assets need to also be versioned and controlled.
All of them.
Yeah.
Because if you're spending money making them, you should version them.
Yeah. Of course.
I just realistically, if you have cost in something, it should be on your Perforce. Like we even keep marketing images on the Perforce.
Yeah. I phrased that poorly. I meant more just I wonder how many different people are touching things that aren't, because like code, you're constantly collaborating on with different people.
So art is the same. There are, I mean, it depends on the scale of your studio. If you're a one programmer, one artist studio, then one person's doing all the art, right?
Yeah.
But if you have 10 people working on the game, then and 8 of them are artists, then probably 8 people will touch a lot of the 6 or 8 people will touch a lot of the stuff in the game. So, for example, if you're talking about a character is a good example. So if you want to make a new character for the game, you have a concept artist probably that draws pictures of what the character looks like, shows them in some different positions, shows some like potential animation ideas, stuff like that. Then that person hands that concept off to a character artist. The character, and oftentimes, especially at a small studio, the concept artist will be somebody who also does other things. They do texture work, or they do like punching up of environments or something like that. They're just good at drawing too. You get a twofer with that person if you're lucky. Sometimes it's the character artist. The character artist will model that character out if it's a 3D game, or draw sprites if it's a 2D game. And then the character artist hands the model off to the technical artist. The technical artist rigs it so that it can move, so that it has, so you can hook it into the animation system of the game. And the technical artist hands it to the animator, and the animator puts the animations on. And that's a never ending job, because there's thousands of like we have dozens and dozens and dozens of stumble animations in our game for like aliens when they get shot, so that when you shoot them in the legs, they stumble appropriately.
The stumble artist has to take over at that point.
It's so many stumbles, but yeah,
I think that's where I was being reductive or overly simplifying the situation. I guess I didn't realize all those disciplines had like abstracted out into different roles as much as they apparently have. Like I kind of was thinking of it from probably a very old fashioned, like full stack, like, well, you model it and then you animate it and then it's done. Right. But it sounds like that those disciplines, I'm sure, just like everything else, things get so complicated that they have to spin out into different roles. Right.
Yeah, and each of those has different strengths, right? Like the person who's good at sculpting a soft body model is maybe not going to be great at figuring out how the movement should work for them, right? Yeah. Like animating is really hard.
Yeah.
Doing the rig is a technically challenging job that also requires people to like technical artist is one of those. Technical artist is like associate editor in the publishing business, right? An associate editor, depending on which publisher, which whether you're at a magazine or website, or what magazine or website you're at, an associate editor could be the lowest person on the totem pole, or it could be the person who does the vast majority of work on the publication, like the frontline work, and then all of their work gets filtered up through other people, right? A technical artist they can be doing rigs for character models or for anything that moves in the game. They can be writing shaders. They can be helping the VFX artist with writing scripts to make the VFX work. They can be hooking stuff like visual effects into the game, right? Like they can be building particle systems or lighting models or all sorts, like crazy broad spectrum. But a lot of that work is stuff like rigging skeletons on and rigging character meshes. Anyway. So yeah, everybody touches everything, and like when you get all that done, then an engineer has to hook it into the game. Like has to actually put it in and say, okay, this can be put in the spawn tables. Here's the AI for it. Here's the gameplay designer will say, here's okay, it has an attack. It has a ranged attack. Is it gonna be a fireball? It's gonna be an ice ball. Is it gonna be a laser? Is it gonna be him picking up rocks from the ground and throwing them at you? And like so 20 people will touch that, even if it's a 10-person studio. Somehow I don't know how that works, but
that all makes sense. So you folks use Perforce. Is that like super common, would you say, in game development?
So in like tech world, Git is what people get is what people seem to use. Engineers like Git because it's really good at doing code. There's a lot of good command line tools, so you can just jam out commits really fast.
Right. Yeah. I'm thinking more once a mass quantity of binary assets are also involved. Like I said, traditionally I think of Git as a text only thing, but you've mentioned here GitHub LFS. Is that what is that?
Yeah, so LFS is their binary tool.
Okay.
We used LFS at Foo with kind of mixed results. It was fine. It was also brand new when we were using it at Foo, so I'm sure it's come along pretty nicely. I think it stands for large file system, but I'm not large file storage, and it basically gives you versioning on binary assets. It's a little like Perforce has been around for a long time. You probably, if you're a small team and you've had somebody who works in DevOps or on production or whatever at a studio, they probably know how to use Perforce. It's not particularly complicated to set. It requires a fair amount of touching, but it isn't complicated touching, if that makes sense.
Sure.
And also, as with many things, the fact that most of the people you'll hire in know how to probably use Perforce is important. The big thing you get from source control is the ability to roll stuff back. So if you make a change, you don't like it, you can say, okay, I only want to do this part of this change or whatever. Perforce does that. The knock against Perforce is it's expensive. Like you get GitHub, both from a licensing perspective per user and from a hosting it perspective, it can be pretty unwieldy. Part of that is because game assets get large. I think at one point our Perforce repo was 2 terabytes. Because we had versions of all sorts of old versions of different stuff and weird offshoot projects and all sorts of other stuff. But you can't self-host it. So you can put it on a machine in your premises, then you're responsible for figuring out how to back it up and all that stuff. But it is a thing you can do. You can also put it on like a $300 a month colo machine someplace and it'd probably be fine. It's free. It's one of those things that's free for the first 5 people. And then once you go beyond that, then you have to talk to somebody and they're like, okay, here's what we're going to charge you.
Call for a quote.
If you have to ask, you're in too deep. But it's reliable and good. And it's what most game studios use is my understanding. If they can afford it. They actually built an add-on for the engineers so that you can just interface with your Perforce repo through Git now, which I thought was pretty funny. So that's
pretty good.
You can do your Git commits into Perforce now.
That's the build environment equivalent of using the Vim bindings in VS Code.
It really and truly is. I mean that's kind of it. It's source control, man. It's important.
So here's my question.
Yeah.
Who manages all of this stuff? Because between the source control and the build server, it seems like you would need a full-time person just to focus on doing all of this.
Well, so it's one of those things that like when we set up the company and when we first started doing nightly builds, one of our engineers set all this stuff up, right?
Okay. Maybe it is automated enough that you'd actually, I mean, I was asking that somewhat facetiously because I was expecting an answer of like, yeah, it sure would be nice to have somebody to focus on just this, but like maybe it actually is more sustainable than it used to be.
It's more, it sounds. Well, so for a long time we were doing a cloud host for the Perforce, which was expensive but nice because it meant we didn't have to do any server maintenance stuff. The server maintenance, it's not turnkey, but it's like, hey, you can spend a couple hours a month working on something and it's probably fine.
Yeah.
If something breaks, then that everything stops while you fix that.
That's kind of what I was thinking about. And this is a weird tangential example, but it made me think back to which Pixar was it? Toy Story 2, I think.
Toy Story 2, yeah.
I believe Toy Story 2, like you can go read about this. There are articles like from the time describing this, like they basically lost the movie.
There's a bonus feature. There's a short on the DVD.
Yes.
It's on YouTube.
I think you guys did some stuff around that, didn't you? I thought I saw some tested work cited. I was reading about that.
When they posted it, Wes did a short post about it, I believe.
That's what I was thinking of. Anyway, like the whole studio ground to a halt because like it was all hands on deck trying to recover work that had been lost. So yeah. I was just thinking along those same lines, if something bad happens where backups need to be restored or XYZ, it seems like having somebody who is permanently on top of that situation would be better than having to like pull people off of their actual work to fix things.
Well, yeah, but also you have to pay that person the time when there's nothing bad happening. So pros and cons. It's again, this is one of those places where like being a Swiss Army knife is sometimes useful because if like you're looking for an indie studio job and somebody's like, hey, what else do you know besides like the thing that you do 20 days a month? And they're like, oh, well, you ran the perforce server at my last studio. It's like, oh, okay. I love PowerShell. Somebody says I love PowerShell scripting in a job interview. You're like, fuck yes, you're my boy.
And then back away slowly.
Yeah, no, and then you never talk to that person again because they're so. And then, so I was gonna say the last thing that people don't think about, I think often, is that you have to have some core source of truth, right? So you need a place that everyone has access to that you put your documentation for how to do stuff in the game. So, for example, if you want to put a new sound into Wise, here's the process for doing that with our game, because it's different for every single game on the face of the earth. Because when you get Wise, you get access to source code and people make source code changes and they build tools that work specifically with your type of game. And like our game has a bazillion lines, external lines of dialogue that are triggered by things that happen in gameplay. And rather than like Wise isn't set up for that. So we have a system that triggers that in the game and then hands off the audio file to trigger to Wise, and then Wise just plays the audio file. That's a completely non-standard way to do that. Normally you would just put the dialogue into Wise and then build a bunch of independent triggers, and it would have been an unbelievable amount of work on our end to hook all that up.
I mean, I can tell you from having fiddled with a zillion open source projects at this point, and also like having recently done a couple of very small utilities myself, like it seems very easy to build bespoke functionality and then not document how to use it.
Look, I don't want to pick on the person who did this because they started on the right path and then got distracted and did something else, which happens a lot at small studios. But I was looking for how to add this the other day, and I went to the wiki page for it, and the thing I saw was this page is a stub. So
everyone loves a stub.
Yeah, everybody loves a stub. But so you want core source of truth for both documentation. You want to also have like work that needs to be done, a place to put tasks that's shared across the team, because there's a lot of stuff that anybody can do or any subset of the team can do, and you just want to have a bin of things to work on. Like, so the way we often would work is, if we had a 4-month loop on a big patch, we would spend 2 weeks working on a 4-week loop on a patch. We would spend 2 weeks working on features. And then the third week would be all the bugs that we found in that time period, in that month, in that 2 weeks, would go into a bug bin. And then the engineers and the artists and everybody who didn't have other stuff to be doing would just sit and just mow down those lists of bugs. And they'd grab the first one out of the pool that they looked like they knew how to fix and tackle it.
Is that I assume that's where terms like Agile and Scrum come in. Those are just different philosophies for managing or for tackling project management and flow and scheduling and stuff.
So yeah, they're higher concept than that. They're like they're more like, it's like if you think about like personal organization and scheduling, like the 40 boxes or whatever, that thing, like it's their frameworks in which you can manage a team's time across disciplines, right? So Agile, I think the core, I'm bad at this because this isn't the side of the stuff I ever do, but I think the idea of Agile is that you ship every X period of time, and you devote a certain percentage of that time to new stuff, and a certain percentage of that time to fixing bugs, and a certain percentage of that time to doing. Scrum is a little bit different approach.
I'm throwing out clearly jargon that I cannot well define myself, but the point is, there are entire modes of thinking built around making this stuff more efficient.
Yeah, this is all stuff that came from somebody reading the Mythical Man Month 20 years ago.
Yes, I remember hearing about that book in the 90s from game developers, or seeing them talk about it.
Yeah, and well, the idea of the Mythical Man Month is that if you have a project that's going to take one person 2 months, and you add 2 people, it's going to take 3 months instead of 2 months, instead of 1 month.
Sure.
So yeah, the idea is that you have to build in some way to communicate and some way to share information, and that's what a lot of these tools are for. So like we use a lot of people use wikis. Confluence is just like a hosted wiki platform that's private, and you can build docs in relatively easily. People use Notion and stuff like that for that as well.
Trello. I feel like Trello picked up some steam because like when Epic launched the Epic Store, they published their Trello board publicly for people to look at to see what they were working on.
So publishing public Trello boards was very popular like 5 years ago. And it's just become a thing that people do. Especially if you're an early access title or something like that, it's good to have a public Trello because people understand it. Trello is more in the task management side. So like the idea, Trello, Jira, stuff like that are what often do that. And they, like with them, you do, you break down individual tasks and subtasks. So for example, in our building a new character model aspect, you'd have a Trello or a Jira task that was, hey, add character model X to the game, right? And then there'd be subtasks for concept, creating the character model, rigging the model, doing the base animations you need to get in the game, adding the gameplay design, adding it to the game and hooking it up to the spawn tables and stuff like that. Depending on how big the team is, that can be anywhere from like a thing that somebody does as part of their job, or if you have a conscientious small team, everybody can just do it. Everybody just manages their own stuff, and then you go through and work down the list together. If you have a like Ubisoft size, Assassin's Creed team, I assume they have like 20 people at each studio that do that work, right? Like they have people on the individual teams. They have some sort of core, or like if anybody at Ubisoft wants to share how you do this, I'm fascinated by it because seems like a nightmarish job. But like I'm sure they hand out tasks like make Rome to Ubisoft Shanghai, right? And then there are notes in there that of places that have to exist. It has to have the Colosseum. It has to have the blah, blah, blah. And, From there, the individual teams at the individual studios parse out what they're working on. And like, because of the scale of that art and the size of that art, I'm sure that like, Ubisoft Shanghai works on one part of the map and somebody works on a different part of the map. And same thing for like Fortnite. Fortnite has a bazillion contributors for it now. Yeah, it's so like that people call that a producer is what it often ends up being. But those are folks that manage the Trello, manage the Jira, manage the Confluence, and help keep the whole team on time. Honestly, having a good Jira, well-populated Jira with the actual tasks and stuff helps you know how much time stuff's going to take more than anything else. Because there are always outliers and like a bug that'll take one person 4 days to figure out or a week to figure out. But often it's just like if it's adding, like if it's building a new map for the game, that's going to be a month, right? For an environment artist, and that's all they're going to do that month. And you can just put that down and know that that's what they're going to do. And then it'll be another 3 months to pretty that up after they've done the first pass. That's
so crazy to think about. Like, again, I know I keep referencing this, but coming off that Romero book, reading about some of his stories about like staying up all night and making an entire Doom map. Like, it's just like, I just decided to stay up all night. And by 6 a.m. I had a finished map that ended up in Doom 2, like just the complexity, the orders of magnitude increase in complexity in building things like environments in the last 20, 30 years.
Yeah, and moving from 2D to 3D was a big one. But then the thing about the fidelity, like I think Quake 1 characters were like 300 polys or something. So, you think about that versus a normal mapped modern first-person shooter game character that's a million polys effectively. Like it's if you, this is why if you want to make a game with a small team, you don't make something that looks like Metal Gear Solid 5 or Call of Duty or whatever. It's because it's too many people. Yeah. There are more people making guns in Call of Duty than working on most indie teams, I think, at this point. So
that checks out.
Yeah. That's why the guns are all animated and cool. And like, that's when they do those cool animations where like the guy is running and he kind of looks at his gun as he's running. He holds up and he does something you've never seen him do before. Somebody spent a month working on that.
I'm guessing that's a month that a lot of smaller studios don't have.
Seems like a bad way to spend your money.
Yeah.
yeah, Trello's good. It gives you public visibility. But yeah, it's important to have that shared source of truth so that if somebody gets hit by a bus or somebody doesn't have time to it's just nice. So you don't have to go ask the person who knows how to do everything to have that documentation.
Yes, absolutely.
You're buying future time for yourself when you write good docs.
Mm-hmm.
But, yeah, so that's it. There's a ton of stuff we didn't talk about here that other people, and also the important thing to think about with games, every single game is different from every other game, including like sequels inside the same studios. Everybody has different processes. What is a producer at one job is a publisher at a different one. And like, there's all sorts of like, it's DevOps stuff is great. This kind of all lives under the shell of DevOps, I think. But yeah, it's kind of crazy. It's a weird thing. I don't think I've heard a whole lot of people talk about it publicly. So it's maybe our nerdy audience will enjoy it. I hope you like this.
Yeah. Hopefully this gives some insight into just the kind of nuts and bolts part of getting a video game out the door.
Yeah. The big thing for me was realizing that like, oh, right. Realistically, most of the time when you make a change to the game, you're not going to get to test it in the game until the next day at the earliest. So it's not like you press compile and then it's on the test version of your iPhone in 10 minutes, like, right. Like a phone app.
Yes.
So anyway,
making
game
games.
dev, making games. Nobody should do it. Every game is a miracle.
Whoa. All right.
No, making games is, I enjoy making games, but it is, we're pushing a patch this morning, actually.
Look, you're not the first nor the 10th developer I've heard say something like that.
Yeah,
that's a pretty widely held opinion.
Literally, the fact that any game ever ships is a surprise to me.
Yes.
When somebody ships a game, they're like, "How did they ship this when it had this many bugs?" And I'm like, "Man, I know exactly how that happened." At some point, you got to get it out the door. But yeah. So if you have questions, please send them in. We'll answer them on the next Q&A at techpod@content.town or the question seeking answers channel on the Discord. And if you're not in the Discord and would like to be in the Discord, you can do so by becoming a fabulous TechPod patron.
You can.
Yeah, everyone. Brad, did you know this is a listener supported show?
I've heard.
I saw a friend of the pod talking about advertising, Jeff Gersman talking about advertising on his Blue Sky yesterday. And I was like, man, I don't want to have to deal with advertising because all it's going to do is annoy people into signing up for the Patreon so they get the ad free version. I'd rather just ask them to support the podcast nicely and say, hey, if you do, we'd rather not have to annoy anyone. We'd rather just have no ads is where I land.
Yeah.
And you can support the podcast by going to patreon.com/techpod. Again, it's patreon.com/techpod. And because you have to say everything 3 times, I'm going to say it again.
Wait, Patreon. I can say it.
Oh, yes. What is it, Brad?
Is it patreon.com/techpod?
It is patreon.com/techpod.
Wait, you said it 4 times. Does that now cancel out one of the 3?
I think more people are going to sign up because we said the 4th. But yeah, so you can go to the Patreon. You can sign up for $5 a month to get access to the patron exclusive episode. Mm-hmm. Last month we talked about a bunch of stuff. People seem to really like it. It generated a lot of conversation in the new episode discussion sub forum.
Oh, and it did exactly what you said it might do, which is that people started posting their own tips, and I got a tip out of there yesterday that made me very happy.
Yep. And yeah, for $5 you can join that. You can join our ranks of executive producer tier patrons who we thank every month, including Nick Johnston, Paddle Creek Games, makers of Fractured Veil. That's coming out in October, by the way. Now, yeah. Andrew Slosky, Jordan Lippett, Bunny Fiend, Just Wedge 3.0, Joel Krauska, Twinkle Twinkie, David Allen, James Kamek, and Pantheon, makers of the HS3 high-speed 3D printer. Thank you all so much.
Yes, thank you one and all.
And that'll do it for us this week. We'll be back next week. I think next week we might talk about iOS stuff, huh? Because it's time.
I've got another idea.
Oh, we'll talk foreshadow. Okay, we'll talk about it offline.
Let's. It's a milestone, let's say.
Oh my.
We'll discuss and we'll see what we come up with. New iOS is imminent. Maybe we should talk about that.
I'm toying with installing the beta. I don't know if it's a good idea or not.
Ugh.
They're not usually beta anymore by this point.
Well, I don't know. After this exploit that just happened.
Well, fair. Okay, we'll see you all next week. Thanks for listening, everybody. Have a good one. Bye.